Hi, this is Erin O'Neill, and I'm doing my lab 8 questions 1 and 4. So for question 1, I drew out this long graph with a metric ruler marking in centimeters, and I had my starting values of F1, S1, H1, lens separation, and F2. So what I did was I started by plugging in where I knew the lenses were. So since the lens separation is 15 centimeters apart, and then S1, which is the length between the object and the lens, is 11 centimeters. I knew that this was 11, this was 15. The height of the object, H1, is 3 centimeters. And then F2, F1 is 4, so 4 centimeters away on each side, and F2 is 6.8, so 6.8 centimeters away on each side. And then I just needed to figure out what the rays were. So I knew that ray 1 would be direct from the object to the lens, and then down through F1 on the far side, and then ray 2 would be through F1. Oops, that's an F1. Into the lens, and then it would go straight. And so wherever those two met was where the image reflection would be. And so at that image, then the next two rays would be going off and reflect off of the next lens. And since they're concave, they're going in this shape rather than if they were they're not concave, they're what's the other word? Convex. Yes, I'm recording my homework. Hold on. So this is convex lenses, and so that's why they're shaped like this. And so then ray 4 goes from that image. This is now the object, basically object 2, and so it goes up through the focus point 2, up into the lens, and then rebounds straight back, whereas the ray 4, or I guess I've marked it ray 3, goes straight into the lens and then ricochets through the next focal point, and then at that angle goes up. And so where these two meet, is like the second image. And so this all makes sense because when you use the math of S1 times F1 divided by S1 minus F1, you do that for S2 and F2, you get 6.29 centimeters and 31 centimeters. So 6.29 is the distance away from lens 1 that the image is viewed at, and that's also where these two lines cross, so that's correct. And then 31 centimeters is, this is 31 centimeters away from where this lens rebounds the image, the light rays, and where these two come into contact. And so this is, right, as you can see, we're at 57 centimeters here, and that's exactly 31 centimeters away from the center of the lens. And so using math, we also find the magnification. And so that will tell us the total height. Oh, I should have put in the height at the end. The height at the end looks like 6.09 centimeters. So this would be 6.9 centimeters tall, and I got that because I found magnification 1, which is negative S1 prime over S1 is negative 0.57, which I know that means it's real, and the negative means it's inverted. And then I take that and I multiply it to find the total magnification by M2, which I found doing the same, negative S2 prime over S2, which equals negative 3.56, again, real and inverted. So when you multiply the two of those, you get 2.029, which comes out to be 203%. So if you take 203% of 3 centimeters, the original height, you get 6.09 centimeters, which is this final height. So yeah, just about twice as tall by the end. And it's going to land at, I guess, 57 centimeters, or at least 31 centimeters away from lens 2 to the right.